Hello everyone, this is Dmitry Andrushka, and today I'll walk you through the HUL 2286, which is about Telco Cloud automation. So, agenda for today's session is quite simple. We'll go through the quick introduction about this lab, then I'll explain you how the lab is designed, and we, together with you, will work through the module 4 of this lab, which gives you overview of the CNF onboarding experience and the TCA capabilities regarding this. So let's start with the introduction. So this lab was developed jointly by myself and Anton Davidovsky. We both presenting service provider and edge cloud business unit and helping our customers to deploy full VMware stack for the Telco workloads. For those who is attending VMworld, Anton will be lead captain during the live session there, and feel free to ask all the questions him during that session. So, couple words about our lab, how it's built, and what we have inside. So basically, our lab built on the several years exercise host with vCenter on the top, and having this foundation SDBC stack, we are bringing up Telco Cloud automation, which consists itself from the two components, which is TCA control plane, management appliance, which communicates to the vCenter, and TCA manager, it is customer-facing UI, which allows you to configure infrastructure and onboard network functions. So basically, during this lab, you'll learn how to utilize CAS capabilities of the Telco Cloud automation, and for the Kubernetes worker and master nodes, virtual machines will be deployed in the form of the nested VMs. So as a result, we'll have several layers of the nesting. For the first layer, it is infrastructure, which is used for this lab, namely ESXi, host, TCA components, and supporting VMs like hardware. And then during the cluster deployment, we have additional level of nesting where we are running our massive Kubernetes clusters. The good news is that all these components are pre-deployed, and you shouldn't worry about the deployment and configuration. So they are already available for you as is. Okay, so from the lab structure, we have 4 modules. First 2 modules are presented in the form of ISIM. It is simulation which gives you general understanding about TCA capabilities and about features which are implemented inside of the TCA. And in module 2, we are going through the CAS capabilities, and you may try to, you will deploy sample Kubernetes cluster, and you'll see how easy you can do it using TCA. For the module number 3, it is cluster validation. So once you deploy Kubernetes cluster, TCA provides you a set of tools to validate status of your cluster and perform set of LCM operations to this cluster. And module 4, which is in scope for this video, and in scope for the hybrid workshop during the VMworld, it has several topics. Namely, they split into 3 lessons. The first of them, it is one of the core capabilities of the TCA, which is called node customization. And today I'll explain you what this node customization means, why we introduced this into the TCA, and what benefit it provides. Then we'll go to the pod, to the real HUL pod, and we'll learn how to design and onboard CNF, the typical CNF, and we'll use dummy and Nginx image, container image, to demonstrate how easy you can do this. And the last lesson, it is effectively a set of common LCM operations which you typically perform during the daily operation, basically instantiation of the CNF, scaling if required, and then termination once CNF is not required anymore. So at this point, let me switch to the first topic of today's video. It is worker node customization. As I already mentioned, it is one of the key capabilities which we are providing with Telco Cloud Automation product. The first motivation why we introduced these capabilities. So as you can imagine, vanilla Kubernetes cluster provides you just generic capabilities, which might be not sufficient for common telco use cases. Moreover, in multiple cases, you need to tune your Kubernetes worker nodes to satisfy appropriate requirements which CNF might have. Example of these requirements you may see here. It is something like CPU pinning of your worker nodes, alignment of them on the particular NUMA node, tuning some kernel parameters or host operating system. All these are examples of the post-deployment settings which should be implemented at your infrastructure to support network function. To address these challenges and to solve these issues, we introduce capability which is called node customization, or you may see that we are referring them as late binding. So how it is implemented? Basically, if you look at the all possible customizations which are typically required to the Kubernetes worker node, we can split them in two large buckets. The first large bucket is all the changes to the worker which are required on the VM level settings. Examples of these settings, for example, putting your virtual machine onto particular NUMA node, or attaching or detaching required network adapters or SRIB settings, or PCI devices pass-through. All these done for the virtual machine itself and the hypervisor level. And we implementing this set of requirements via so-called VM config operator, which is part of our SaaS solution. And this VM config operator communicates directly to the vCenter and modifies worker node virtual machine settings according to the required specification. Another set of customizations which are typically required, it is modification of the host operating system, basically of the Linux operating system where the worker node runs. Examples of these modifications, quite a few. For example, it is installation of the custom packages which are required to run given network function, installation of the dependent libraries, modification of kernel settings, or even modification of the kernel itself. For example, if you need real-time capabilities of the worker node. All such settings are made using a special operator called node config. And this is a part of Telco Cloud Automation tool, and it supports these and many more other features. So in summary, with worker node customization, we can do two levels of modification. One of them is modification on the virtual machine level, and another on the host or operating system. This is implemented using two Kubernetes operators called VM config and the worker node config. And with these two operators, we can satisfy almost any requirements for the given network function. From the implementation point of view, it looks like this. So at our control plane operator, we are running set of components which are talking to the operator which you mentioned. So basically, as we already discussed, VM config operator talks directly to vSphere VMs and modifies settings and configuration of these VMs according to the requirements which are specified in the network function. In the meantime, node config operator is executed inside of each worker node, and it modifies given worker node according to the specification. So all this is already implemented inside of the TCA. The capabilities which we provided is worker node customization are well documented at our TCA official documentation page, and you may take a look to understand full capabilities which are supported with this function. Yeah, at this moment, let me switch to the next lessons of our HL lab, which are regarding CNF onboarding and CNF LCM operation. For this, let me switch to the real HL lab, which is which we run in at our, and let me walk you through the setup which we have. Okay, here you may see a typical environment of the HL lab. I'm already at the module 4. We just discussed with you node customization theory and how it is implemented and what is why we need this feature. And now let's look at the environment which we have in the HL lab. So let's click at the browser and let's start with the components which we have here. Click on the region 1 and first let's open TCA Manager. TCA Manager is the user interface which we are using to manipulate and to manage all the network functions which are imported, and additionally provides capabilities required for the infrastructure management and infrastructure automation and things like SaaS infrastructure. So Telco Cloud Automation is already pre-configured, and once you're logged into the interface, you may see that under the CaaS infrastructure, we already have two Kubernetes clusters. One of them it is called TKG Data, another is TKG Management. So they are management and workload Kubernetes cluster respectively. So we are going to use TKG Data to deploy our network function. However, before we'll do this deployment, let's click at the partner system. And here at the partner system, we see that there is integration with hardware, which is a primary artifactory used for a typical Telco deployment. So if you click here, you'll see that there is configuration for this hardware. And let's just open new window and log into the hardware. So click on the region 1, and now let's click at the hardware. Okay, hardware page is loading. Credentials are already saved here. And let's log in. So just a quick introduction. Hardware is artifactory, namely container registry plus Helm chart storage for the network functions which might be deployed through the TCA. Hardware has many interesting capabilities, for example, synchronization with another registries. It can do image scanning and many other features. However, for our sample lab, we just using Harbor at the Artifactory storage. Basically, we are storing containers here for our network function, and Helm chart storage. So all the artifacts which might be uploaded into the Harbor split into the project. And right now we have a project called library. Inside this library project, we have one container image called Nginx. So you may see that this is a quite generic image, which is available as an open source artifact. And if you click here, you may see details of this image along with specific settings. So during our lab, we are going to use this container image to instantiate it on the top of our infrastructure using TCA. The next thing which is important for us, it is Helm chart. And here we, in typical scenario, we'll see here all the Helm charts which were uploaded to the Artifactory. The common scenario for the network function deployment and for the real life is that network function vendor provides you a set of container images together with Helm charts, which are used to deploy these network functions. Both container images and Helm charts used to design network function, and during instantiation, TCA is pulling container images and charts from the harbor and deploy containers in the Kubernetes. So that's why we are generic assuming it that both container images and Helm charts are coming from the network function vendor. However, technically, you can deploy both container and Helm chart by yourself and use them for deployment through the TCI. Okay, let's click on the Nginx Helm charts, and we see here one quite important thing. It is version of the Helm chart. As you can imagine, your network function can be in different versions and in different flavors. So from the artifact perspective, you may have different versions of the Helm charts in your Artifactory, which further map to different container images and different versions of these images. Thus, using different Helm charts, you can deploy different versions of your network function, and later you can update and upgrade and downgrade your network function depending on the requirement. So in our case, we have Helm chart with version 8.9.0, and this Helm chart has set of input parameters which are used to configure a network function appropriately. Once again, it is vanilla image. It means this Helm chart is coming from the open source, and you can review it at GitHub and check which parameters are accepted by this network function. Okay, so Harbor is here. It is integrated with the TCA. And now let's move to the network function section. And in this section, we have quite a few capabilities. But typical starting point here for the network function, it is onboarding process. So technically, during the onboarding, you can do a couple of things. First of them, you can onboard existing network function package. Your network function vendor can provide you CSR package, which has all required artifacts for your network function instantiation. This CSR package should be built according to the HC specification, basically according to source specification, and it should have a specified structure And inside of this package, there should be file called VNFD, basically VNF descriptor in the form of toast specification. And using this VNFD, Telco Cloud Automation will deploy your network function appropriately and create all required resources. In our case, we have no CSAR package. We have no database archive, so we are going to design our network function from the scratch. Let's provide just name. For the example, it will be Nginx. And we can design either VNF or CNF. In our case, we'll focus on the cloud native function. And let's click design. So when you're starting, you should fill metadata about your network function, which has a set of optional parameters like version of your product, software version of your package, and stuff like this. So all these fields are defined in the HC specification, and they used, for example, when you have several versions of your network function package. Okay, let's keep setting as default, and let's update just this. So when you provided metadata, you'll see this canvas where you can design your network function. Technically, you can put several Helm objects on this canvas, which represents your network function in a whole. Because as you know, network function might consist of multiple container images or from multiple deployments, and itself, this network function can be deployed using several Helm charts. In our case, let's take this. Let's take Helm here. So drag and drop Helm object here, and we'll see the new window which we specify, where we specify a setting specifics to this Helm object. Let's call it something like this, Nginx Helm. Chart name. Okay, well, no, open this way. Chart name. This is a reference to the chart which is available in your artifact. It should match to the artifacts which you already have in Harbor. Basically, if you scroll, switch back to the Harbor, here in our library artifacts, we have Helm charts called Nginx. And this name should be specified for the Helm object during the network function design. So we should specify here Nginx in our case. And chart version is important parameter too, because this field specifies which version of our Helm chart we are going to deploy at the infrastructure level. Let's click on Nginx chart here. As you remember, we can have many different versions of the same Helm chart, and version is 8.9.0. Okay, Helm version is version 3 in our case. Technically, we have support for Helm version 2 in case of legacy NF. And for other capabilities, which are quite important for us, is Helm properties. As you probably know, during the instantiation, we can specify, or we should specify a set of input parameters which are used to deploy our network function. Helm parameters typically specified in the form of key values pairs, like key and appropriate values. Another option is to specify YAML file in which all these parameters are summarized in the form of key value. And let's do the following. let's specify input file as file and call this property as input. By this, we assuming that to instantiate our network function, we should provide key value file, which will be called as input. And let's make this setting as required. The remaining items are not important at this stage, and let's just put several tabs. Let me move down, 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 down to the end. Okay, let me update. So we updated our Helm object. So basically we specified chart name, chart version, and we will specify that during the instantiation of this network function, basically via this Helm chart, we need to provide input parameters file. Okay, so technical design for the basic design for the network function is done. At this moment, we already can upload this network function into the catalog and use it to instantiate our network function. However, if we check here, we have additional settings like infrastructure requirements. So infrastructure requirements, this is something which allows you to configure worker node customization. As you remember from the deck, which we discussed recently, we may tune worker node and VM setting itself using this capability. Let's configure quite basic. Let's review and then configure some basic capabilities of the worker node. So you may see that using these infrastructure requirements, we can specify different requirements for the infrastructure and for the worker node. For example, we may specify network adapters, which should be attached to the worker node, additionally to already existing. We may specify pass-through devices, which should be plugged into the worker node. And definitely we can specify many different settings for the host operating system, our worker nodes, like kernel parameters, like files, and stuff like that. So let's do the following. At first, let's look at the source. At the source, it is our Tosca specification of our network function. This Tosca specification is built according to the ETSI standard, and you may see the different low-level definitions of our network function. In the resources, we may see structure of our package. So if you later decide to download this package, you'll see near this structure, I mean several folders, and inside of these folders, there will be some files which are used to process this network function. In the artifacts, typically we have supporting files like different scripts which might be used during the deployment or any LCM operation. And let's add a generic file here. Let's choose it. On the desktop, you will see that we have a very simple file called readme.txt. So let's upload this file. In real life, it can be for example, some post configuration script or some configuration parameters or any other artifacts which you, for example, need to have in your network function. Now let's move back to the customization page, and let's enable a customization here. So as the example of this customization, let's upload that file from our package to the worker node. On the file section, let's click on the add. And here we will see that in artifacts, we have readme.txt file. Let's select it here. And at the next input, we'll specify destination folder. So let's put this file into the worker node under the TMP folder, and let's call it txt. Okay, so the objective of this operation, we are adding some artifacts like scripts, file configuration file, some automation playbooks into the network function package. And here we specify that please copy these artifacts to each worker node in my Kubernetes cluster where this network function will be deployed. So basically, before network function will be deployed, TCA will customize infrastructure. Basically, it will perform all the actions which are specified in the worker node customization section. Okay, let's finish here. Let's upload our network function to the catalog. And now you see in the catalog, we got our engine function. You can click on it and verify what we have inside of this network function. Basically, inside of this network function, we'll have information about the structure of our package, together with all custom artifacts which were uploaded, if any. And yeah, in infrastructure requirements section, you'll see details what is the infrastructure requirements, and basically that's it. So now we are ready to instantiate our network function. We are clicking instantiate link, and a new page is opening. So at this page, we should provide set of input parameters required for our network function. At first, let's start with the name. So it can be a generic name. Let be, in our case, it will be engines. Okay, the next step is quite important. We should select destination cloud, basically destination Kubernetes cluster, where our network function will be deployed. In our case, we have just single Kubernetes cluster. Let's select it. And your Kubernetes cluster might have several node pools, basically groups of the worker nodes, where you can deploy your workloads. Let's try to deploy network function into the node pool 1. And at the next stage, you will see that you will see summary of the required customization to deploy this network function. In our case, we just copy files, so we are not performing any modification of the worker node itself. However, if you decide, for example, modify kernel version or modify some kernel parameters, at this page, you will see summary of all changes which will be performed for your worker node. Okay, let's click OK here, and now the cloud is selected. And now let's wait a while. It will be analyzed. Let's click next. Now, here is the destination namespace. Basically, network functions are deployed on a pure namespace basis. Let's call it something like NF. And here you should specify repositories from which TCA should get all the artifacts, basically Helm charts and container images. You can either specify a repository as via input parameters via URL and credentials, or you can select one of the repositories which is already integrated with TCA. In our case, we have Harbor repository, which is already integrated with TCA. Let's click next. Here we'll see that we are going to deploy one Helm object. And on the next page, we should provide input parameters to deploy our network function. In our case, it will be quite simple YAML file, which just specifies replica count. On your desktop, you already have this file called engine scale. Let's select it here and open. Yeah, and you cannot see, but here due to size of the screen. But here you can see here you have just parameter called replica count, and you will see value which is set to this parameter. Let's click next. Fortunately, it's small too, yeah. And let's click instantiate. Okay, so instantiation operation was started, and if we'll look at the progress, we'll see several steps here. So the first step in the instantiation process is a reconfiguration of the infrastructure. So basically, if you specified infrastructure customization, TCA will start with that section. So in our case, TCA right now is reconfiguring infrastructure. So basically, it performs all the operations which are specified there. Namely, it takes a file from the package which we specified, I mean, a readme txt file, and copies this file to the destination host. It will take some time to complete this operation. And in case if the worker customization and this step is successful, the next step is the instantiation of the network function itself. However, if the infrastructure customization will fail, all the process of the instantiation will fail too, and we should validate what's wrong with the specification and what we can do to resolve this issue. So let's wait for a while for this step to be completed. Okay, it took 3 minutes to perform worker node customization, and as you can see, this task was performed successfully. The next step in the instantiation process is so-called run request, and at the run request, TCA validates all the dependencies which are required for the network function instantiation. In most cases, it is quite fast process because it's just validation from the resources perspective and what is required for this Helm chart to be deployed. And the last step of this process, it is instantiation of the network function itself. In our case, it is very simple network function, which consists of the single Helm chart. But in production scenarios, your network function might consist from many different Helm charts, which should be deployed one by one in a specified order. So let's wait a couple more moments, and we expect that network function instantiation will be complete. Okay, good. Let's double check. Let's double check instantiation process. So it took 3 minutes to perform worker node customization and basically copy file from the Artifactory to the worker node. When during 1 minute had run request, which validates all this specification included into the network function descriptor and match them to the infrastructure capabilities from the resource perspective. And the last 2 minutes, it is the instantiation of our network function. Okay, now let's check what we have at the infrastructure level. Here we have PuTTY, which is pre-configured for all hosts. And let's scroll down. Here we have entry for our Kubernetes cluster. Let's open connection to TKG data. Authentication credentials already provided, and we logged into the Kubernetes cluster. Let's here using kubectl, let's check namespaces. Okay, definitely it is error. So as you can see, we've got a new namespace called NF, and it was created 2 minutes ago, which is fair considering time when the network function was instantiated. Now let's look. Okay, so we may see that 2 pods are running. So basically, our network function was instantiated successfully. Okay, so we validated what process was successful, and everything is running as expected. What is the next? So typically during the operations of your infrastructure, your network function, you should perform a set of modifications, set of operations with your network function. According to ETSI specification, there are a set of interfaces or operations which are predefined by this organization, and these operations, known as LCM or lifecycle management operations, are supported with DCA via inventory menu. So what you can do typically, as you can see here, you can scale your network function, basically change replicas. You can reconfigure, once again, modify input parameters. For sure, you can terminate your network function, and you have several variations of update and upgrade operation, because you can update and upgrade different things. You can update package of your network function itself. You can upgrade for example, container images which are deployed, and stuff like that. That's why we have different operations. But at first, let's look at the scale operation. Scale operation is quite simple. As you remember, at previous step, we've been using this file, input file input file for the network function deployment. Let's open it here. So as you may see, it specifies replica count parameters, which is effectively number of pods to be deployed at the infrastructure. Let's change this parameter to 1. Let me save this YAML file, and I'll be using it to demonstrate scale operation of the network function. Okay, let's click scale here. And as you can imagine here, we should provide input file. Let me click browse. Let me click next. No, nothing specific here. So, and let's click finish. So we'll launch scale operation, and what will DCA do right now? It will identify Helm release name of our network function, and it will reapply scale operation using Helm capabilities and input file which we just provided. So you may see here that it's updates deployment. it should be quite fast. And yeah, here we can see that it is success. And let's check what we have at the infrastructure level. Let's check status of our operation. Yeah, and as you see right now, we have only one pod of our network function, which is run. So scale operation was performed successfully using input parameters. Okay, once you've done with your network function, or once you're not required, you always can terminate it. Terminate operation is quite simple. You just select terminate LCM and click finish. Technically, during the terminate operation, you can perform additional steps if required. We supporting the concept of pre and post workflows. And for example, you can pre-clean up something before your container images will be deleted, or perform some post termination operation once again if it is required. So let's check. Terminate was successful, and let's check what we have at the infrastructure level. So as you see, there are no pods in this namespace. However, the namespace itself is still present here. So this means that terminate operation was successful. So once you're done, and once your network function is terminated, you can remove it from the inventory using delete button. Yeah, so basically that's all we wanted to demonstrate it for you regarding module 4 of HOL 2286. And if you still have questions, please feel free to ask myself or Anton, or by either over email. And thank you for your attention.